From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker.
And I'm Kaushik Gopal.
Welcome to the show.
If you work on an Android app, and if you're listening to this podcast, I'm going to presume you do, you will know that when your user reports a problem or a crash, it's the absolute worst feeling. To make matters worse, they might one-star your app, go on Twitter and complain about the app, and if they're feeling particularly merciless, probably go on Reddit or something and post it there. But you know what? They have absolutely every reason to. If you treat your customers basically as an offsite QA team, it's rude to them and it's just bad for business. As developers, we don't want to rely on customers to report errors. Instead, we want to catch this much early on. Ideally, you just have automated tests and these tell you when there's a problem. But as we've talked about on the show multiple times, that's not always as easy as we want it to be, because writing tests can be hard. That's why Sentry, our sponsor for today's show, tells you about errors in your code before your customers have a chance to encounter them. Not only do they tell you about the errors, they also give you helpful details that help you fix these errors. For example, how many users were impacted by this bug, the complete stack trace if it's a crash, the commit ID when this error was released, the engineer who wrote this line of code that was busted, that and a whole lot more. If your code is broken, let's fix it together. That's Sentry's tagline. Love it. You can check them out at sentry.io/for/Android. Sentry is a pretty common word. It's actually a pretty cool name for the service if you know the English meaning of the word. But I want to make sure you get that domain name right. It's sentry.io. Once again, sentry.io/for, as in FOR/Android. Check them out today and fix your errors before your users encounter them. Thanks for sponsoring today's show, Sentry.
Welcome back to the show, everybody. It's been fun. There's been lots of stuff going on here in the Android community and the Java community and the Kotlin community. There's all kinds of things going on. It seems like every day there's like a new library, some new type of method going on. And kind of one of the reasons we're here today is to talk about something that recently has come out. And that's actually a topic that we get asked about on the show here quite a bit, and that's testing. And today I wanted to bring on someone who has a background in testing and has kind of worked quite a bit in regards to that, especially in recent updates to JUnit 5. And without further ado, I would like to welcome Marcel to the show. Welcome to the show, Marcel.
Hey, Don. Thanks for having me.
No problem. Thanks for joining us today. It's going to be a super exciting show here because testing is one of the things that Kaushik and I have talked about many times on the show. And in fact, if you go back, I think our first episode was on testing itself. And it's still to this day one of the most highly requested topics that we have continually. So this should be a good one here today. And the reason why I want to talk to you, Marcel, is because, like I said, you have a background in testing, and I've spoken to you numerous times over the last year regarding some topics mainly about JUnit 5, and you have quite the breadth of knowledge in it, so it would be great to have you on the show to talk about it. But before we hop into everything in regards to testing, for folks that may not be familiar with you, kind of your background or who you are, would you mind giving the folks a little bit of background information on yourself, maybe where you work, kind of what you do, how you got into Android, why you're interested in testing and so forth?
Sure, absolutely. So my name is Marcel Schnelle. I'm a freelance developer from Germany, currently working remotely for Japanese clients in the drink vending industry. So you know how in Japan there's vending machines all over the place.
Oh, yeah.
We're building hardware and software so you can basically buy drinks through your phone when you approach the vending machines.
Oh.
So that's what I'm doing mainly. I got into Android around 2010, 2011, was at university. We had to do a mobile course, and I got into that. So I don't go back as far as the G1, but I've been around quite a long time now, since about Gingerbread, I think, was my first phone.
Yeah.
And professionally since 2013, been doing Android most of the time.
Well, fantastic. Now, what got you into into testing in general? Because I mean, that's kind of how you and I connected is just talking about testing, and you did some stuff for Caster.io, and it was regarding testing. And you seem to have quite the breadth of knowledge in the area. What got you interested in software testing in general?
Seeing the code base at my first job out of university, really, it was not like a too terrible code base or anything, but it was big enough that I had this kind of lack of confidence in trying to approach it or change it or extend it. And that's when I looked into how we can get confidence in that code base and how we can find an automated way of verifying and validating that code that laid upon me. And that's when I found JUnit, and I noticed how it had been around for years at that point already and matured. And ever since that initial point, which has really burned itself into my memory, I've introduced test structures in all of my clients, all of the jobs that I work for, the agencies. Regardless of language, testing has always been one of the first priorities I go for.
So you're talking about like when you, let's like you said, I make a line change in some code, and then it happens to be like 6 screens deep past my login screen, and I have to test that. But then I got to compile, I have to install, and then I got to log in, then I get through 6 or 7 different screens just to test it. And I'm 2 or 3 minutes in at this point, and then I realize, that change is not what I wanted. Like, that's wrong. Okay, let me go redo this cycle over and over. And it was just like a really slow feedback loop. Would that be about right?
Yeah, precisely. And then the build times during that time didn't really accommodate that kind of type of working environment either. So that's what really got me interested in it. Yeah.
So when you started doing some of the testing that you were doing, did you find yourself, following, a certain type of testing? I know there's different types of testing out there. We have like unit testing and integration testing and system or end-to-end testing. Is there one that you kind of started off with that kind of got you, jump-started into the process of testing?
So at first, before there was a conscious effort to write code that is testable, before that, I initially got into very high level, almost like end-to-end tests on the basis of Espresso, for instance, in Android speak, just because the components themselves were not isolated enough for them to be unit testable. But then as time went on and I had this back layer of confidence in the code, I was able to just pull out these components and then unit test those. Today, I usually go in the opposite direction, where when I write a component, I usually go for the unit tests first. But again, that's the result of a conscious effort to make this testable in the first place. And I still do see the amazing benefit to having these system end-to-end tests in the code as well.
It's a good point, because there's a lot of people that talk to me and say, hey, I want to write tests. I don't know how to write them, or I don't even know where to start. And I usually feel that that's a symptom of just a poor system design and usually a lack of experience in regards to testing. And it seems like you've kind of been there. Now, would you agree that maybe if someone is in that scenario, a listener's in that scenario, or to say, hey, I don't have any tests, making these changes is really painful. And in fact, I'm scared to make changes because I don't know what I'm going to break. Would you say that writing some Espresso tests would probably be the best bang for their buck initially?
Yeah, I'd say so. Definitely. Especially if your components are tightly coupled and there's dependencies all over the place. Maybe even start with Espresso tests that really do hit the network. If you can't mock it out easily, whatever, just start with that and then work your way down.
I totally agree with that. As you know, I'm also a freelance and consultant and so forth, and do tons of contracting with all types of companies. And very often I'll show up at a company, and I'm sure you've had this happen. You show up at a company, they have 0 tests, and like you said, like there's nothing that you can mock out. You don't have the time to refactor a bunch of stuff, but you just at least you need to have some type of smoke test to know that when this, I push this up to continuous integration, that some tests run, I can at least start the app. So the app starts, and then maybe I can just at least log in, and it does hit the actual production servers, and you just happen to have like some fake account or some account that's actually a real account but at least allows you to verify that behavior. So I definitely have been there. many times. Is that what you've also encountered too a couple times as well in your consulting career?
Yeah, 100%. So usually the test source set is the first thing I open when I actually go on board, and then I check what is the state of this thing that I have to work on now, and how can I build confidence in what I'm doing is actually the right thing. So I feel like, yeah, I've been there. I've had test accounts created for me or created them myself. Maybe even on a staging server, like if you want to go level 2, maybe there's a different staging server, but it's still real network calls. Just start there.
So let's kind of riff on that for a minute there. We have someone who's maybe said, okay, I know I've created the, in my opinion, and please let me know if you disagree with this, the first test I always create if there's no test is just a test to know when I start the application, does the app actually start? Because your app may compile, but you may have some weird, reflection thing going on, and it may, as soon as you hit the icon, it just blows up. So that's usually the first test that I write. Is that a similar thing that you do, or do you do something different?
That kind of launcher test is always one of the first that I also write, because I would lie if I said that didn't happen to me before, where I just made the change and I said, well, yeah, that's such a basic change. Whatever, just hit build, send the APK, and first thing it comes back 2 minutes after from QA is, yeah, can you kind of do that again? And then I actually click it, and then of course it's the most ridiculous mistake, and then I have to build it again. And that kind of launch test is the best safeguard against that. And I think even Google Play, they do that, right? I mean, they do analyze the stuff you upload there. And I think just launching your app is one of the tests that will blow up in your face on the console if it doesn't pass.
That's right. I forgot about that. I mean, back in the day when you started and I started, like those things didn't exist. You just uploaded your APK and you were off to the races. And
right.
If it blew up, hopefully you had some type of bug tracking and you get notified. But yeah. So let's say that some end user has perhaps this end-to-end test set up. At that point, usually the next question is like, all right, I have these tests kind of set up, but I need to start, these tests are slow. They're kind of hard to write. I would like to start having a better system design. What's usually the next step that you recommend folks going from this end-to-end system, and how do they get to that next step?
I suppose that depends on the size of the code base that you have to work with and the speed at which the client or the company you work for wants to evolve in. Mm-hmm. If it's mainly about changing existing components and extending them, I would approach it differently than if I were to completely write a new component from scratch and just connect it to the existing. Mm-hmm. Because based on that, again, you have the interdependencies between components, and then you'd have to if you were to change existing stuff, you'd have to kind of break it into interfaces so you can change them out and during tests, and then kind of isolate these small islands of the code base so that each of those can be then lifted out and then back into a test environment again. Whereas if you have the luxury of starting anew or like writing a new component, you can build it from the get-go to have these interfaces. But if you're not so lucky, then there's books on it and there's approaches to it, and then you can isolate your code.
Yeah, one of the things you said there was one of my favorite sayings, and that's islands of testable code or something like that you said. But the word islands is what sticks out to me. And the reason why that sticks out to me is because that was mentioned by Michael Feathers in the Working Effectively with Legacy Code book. And for some reason, out of all the pages in that book, that struck a chord with me, because it made me realize, like, every time I write a test, I'm basically creating a new island, a new safety area, that if I go there again, it's already covered. And if I make a change there, I know I'm going to be covered by some type of safety net. And if I don't, I could drown, if I could fall in some water, etc. But every test I create is a new island of testable code. And then the other thing that you said that I also resonate highly with is the interfaces. And that's actually also covered in a lot of books, but especially in Working Effectively with Legacy Code, where Michael Feathers talks about, well, if you have, and especially the chapter names, like if I don't know how to make a change and I'm scared or whatever, like, what do you do? And one of the things he always talks about is like, all right, well, sometimes you have to introduce a shim and an interface or a shim. And it's kind of just like, putting this weird thing out in the middle between two different dependencies. Like, all right, well, this thing talks to a content resolver in Android and it's inside of this, whatever screen. Like, how do I break that out so I can mock that out? Because maybe I can't in my test environment. I don't have any contacts in my contacts, in my phone. So I need to kind of mock this out. So you kind of put that shim in there. So I totally agree with all those things in there. Now, when you're writing these tests, you're using Espresso, and then of course we're going to use a unit test, which run faster, of course, because they're running on the JVM. But we're kind of, from what I've been able to gather, we're always using the same framework, which has always been JUnit. Now, there's been a new version of JUnit that has been released that not many folks have really talked about, and that's JUnit 5. Would you mind talking a little bit about like what is JUnit 5? Maybe when did it come out, and something we should upgrade to, or anything of that nature?
Yeah, absolutely. So the obvious statement first: JUnit 5 is the successor to JUnit 4, which, as you mentioned, is the ubiquitous and go-to solution for unit testing on the JVM, pretty much. And the last version, as of the recording of this episode, of JUnit 4 is, even though there's a release candidate, it's still 4.12, and that was released sometime in 2014, so it has been a couple of years. At this point, it's so robust, and what are you going to change it? But it has been met with a bit of a difficult time trying to extend upon JUnit 4 at this point, and that was the initial impetus for the core team of the JUnit team to start a crowdfunding campaign in 2015. Looking for the funds to dedicate some time and work on the successor of this framework that we all know. And it took over 2 years from that initial crowdfunding campaign until the actual initial general availability release. That was in 2017, in September, I think. And it has taken this long because the team wanted to get everything right, because it is a complete rewrite. So no code was reused from JUnit 4.
Oh, I didn't know that.
There's no transfers outside of the knowledge and the experience they had with the battle-tested predecessor. And it brings more modern programming concepts to unit testing. So it is definitely worth upgrading, I feel like, yeah.
So that's a good question there. Is like, I hear you say like, all right, they didn't reuse any of the code. So as someone who has, at this point, close to a decade worth of experience with JUnit 4, it seems, is my knowledge, you said something about knowledge transfer. Is all that knowledge going to transfer over, or am I going to have to learn a brand new API and everything, or is a lot of the stuff the same?
A lot of this stuff is the same. I would say mostly everything is the same. So there's no just new programming way of describing methods. You still write your test classes, you still write your methods, you still annotate them with an annotation that's named test. So the foundation and the basis is still the same. It does look, from the outside, it does look more complex, and that's because it is more extensible. And that goes into the point of it being kind of split up in different modules. Mm-hmm. But at the core of it all is still the test annotation that we all know. And even though concepts might have different names, like the annotations might have a different name,
okay,
you can do everything with JUnit 5 as you can with JUnit 4. And then on top of that, there's a good and modern foundation upon which you can build all these other cool features that it brings.
Awesome. So, which we're going to hop into some of those features in a second. But one question it's kind of been burning in my head for a while now is, I know that JUnit 5 has been out for a little bit. Why are we still using JUnit 4 all over the place? Do you have any clue?
Well, because it's everywhere. And especially in the Android context and Android environment that we live in, a lot of the stack that we use is pretty tied pretty closely to JUnit 4. So just getting that out of the way right now, roboelectric tests currently do not work with JUnit 5. So you have to be using JUnit 4 in order for them to work. And we can go into more detail about why that is. It is that, I feel like, and then coupled with there's no first-party effort right now from Google's side to push for JUnit 5. There's actually, not giving him enough credit. So the release of the Android X test libraries that have kind of broken down the activity scenario API. If you use that before, it's kind of it's a device independent way of asserting tests. So it runs Roboelectric and it runs Espresso tests with the same kind of facade. That API has been absolutely essential in the support that we have going forward with JUnit 5 in terms of Android tests. But yeah, I feel like it's just everywhere, and build tools and IDEs and everybody's grandma uses JUnit 4 to some extent, and that makes it one of the biggest advantages, but also one of the biggest drawbacks of JUnit 4, and that's why the team wanted to build upon that.
It reminds me of the old Python 2 to Python 3 conversion, where it just took forever for everyone to get to Python 3 because everything was in Python 2 for so long.
That's a good analogy. It's not that different syntax, but it just took forever. Yeah.
So that's a good question. It's all right, so we have JUnit 4 all over the place. I use it. You use it. Everyone who listens probably uses it. Now, as people are starting to maybe kind of become interested after they listen to this show and learn about what JUnit 5 has to offer and its new features, they were probably wondering all right, well, can I even use this with Android? So let's just answer that question out. Can I use JUnit 5 with Android?
Yes, you can use JUnit 5 with Android.
Is there anything special that I need to do that?
You would pull it in like you would any other dependency. You'd grab the coordinates and put it into your build file. And then you could start writing your unit tests. It is a rewrite of the library, but that doesn't mean that the core concepts have been thrown out the window. There is native support in Gradle for JUnit 5, or rather the JUnit platform. And I think that was introduced in 4.6, I think. So ever since Gradle 4.6, you wouldn't really need anything on top of your build system, which you use anyway, to use JUnit 5. But the Android environment, where we have the different build variants and filters per build type and stuff, that of course doesn't come from Gradle itself. So with that helps a third-party plugin that you can hook in, and that kind of sets up your Android specific project for JUnit 5.
Is that the Android JUnit 5 plugin?
That is correct.
That's something that you've contributed to as well, or is that something you wrote, or what?
Yeah, that one is mine. It was initially a pull request on the JUnit 5 repository, and that goes back a couple of years. It never really got merged because the team was so busy moving with all the milestones that I eventually decided it would be better just to pull it out into its own project and maintain it ever since. Yeah.
Okay, cool. Well, I'm going to add that JUnit 5 Android plugin to our show notes here. So for the folks that are listening, if you're interested, after you listen to the show, you want to give JUnit 5 a try, you want to kick the tires a little bit, definitely check out the plugin in the show notes. And then, of course, if you have questions, you can always reach out to Marcel afterwards. So let's hop into some of what JUnit 5 kind of offers us compared to JUnit 4. And one of the things that I learned initially when kind of poking around at the JUnit 5 user guide, which we will also put in the link in the show notes, is there's this concept where they say JUnit 5 equals the JUnit platform plus JUnit Jupyter plus JUnit Vintage. As soon as I read that, I was like, whoa, what is this? And they explained it a little bit, but maybe you can break it down for our listeners what the differences of the platform, Jupyter, and Vintage are and why they're important.
Sure. It's the most essential equation of JUnit 5, I feel like. So JUnit 5 is, as a name, is the sum of these three parts that you just listed. And each of these has a different responsibility in the grand scheme of the whole framework. So first up would be the platform. And that's, in a nutshell, the integration point if you were a build tools developer or a SDK developer, or you building your own test framework on top of JUnit. Then you would use the platform to hook into the execution of tests. So it's an agnostic framework for running tests, pretty much.
Okay.
And there's a central interface here. It's called Test Engine. And then if you were to design your own library, for instance, the developers of Spec they actually implement that test engine interface for their framework.
So does the spec use JUnit 5?
Yes, it does. I think it's required. I don't think it works with JUnit 4.
Oh, interesting. I didn't know that.
As a user and the writer of tests, you wouldn't really interact with the platform. It's mostly reserved for build tools developers, so the folks at JetBrains and the folks who write the test frameworks. It's not even necessarily tied to the new programming model for JUnit tests. It's just completely agnostic. Which brings me to the second component, which is Jupyter. Mm-hmm. And that is the new programming model for JUnit 5 tests. So that's where the annotations live, and that's where all the features that we're going to spend a bit of time talking about live. And also it has an extension model. So it is really, really extensive.
Okay.
Just in a nutshell, we're going to go more deeply into this, but in a nutshell, it's the replacement for what we have in JUnit 4 with rules and runners. You've been unified into a single concept, which is extension, and that allows for custom logic in your test fixtures.
I'm interested in that because I've always felt that the whole rule and runner thing was just confusing to me. So I'm excited to talk about that.
Yeah, it was as far as I understand it, it was also a bit of a solution out of a problem they had where, you know how there's only one runner per test class.
Yeah.
And so if you wanted to use Mockito and I don't know, the parameterized runner, you couldn't really do that until they introduced rules as kind of a backup strategy. So you can compose rules, but you couldn't compose runners. Now it's the extension point API. And because we're in Java 8 land with modern programming concepts, these are all repeatable. You can slap as many extensions as you want on your class. And so it's a much better way forward.
Nice.
And then the last component would be Vintage. It's pretty much a fancy name for the backwards compatibility layer. So just like with Kotlin, you're not committed to upgrading your entire test code base at the same time to JUnit 5. So like Kotlin can coexist with Java, JUnit Jupyter tests can coexist with older tests. And you slap in the Vintage engine. It's again an implementation of the test engine interface to just run the old tests on the new platform, pretty much. And in fact, that's also really good for us as Android developers because, as I said before, Roboelectric currently doesn't work on JUnit 5. So you would still keep your Roboelectric stuff in JUnit 4 land. You can still execute it on the platform, though.
Oh, so I could still upgrade to JUnit 5 and say, hey, you know what? Actually, these set of tests over here, I want to use the Vintage stuff, and it would then run on the old JUnit 4 style. Is that what would happen?
Absolutely.
Okay, so this is really important because I feel there's a lot of people out there and a lot of companies, teams, whatever, that have developed a very extensive set, and I'm part of some of these teams, very extensive set of tests that have thousands, if not tens of thousands of tests that are written in JUnit 4. And if they want, they can say, hey, all right, everything in these packages or suites, I'm not sure how it's filtered, and we'll talk about that. How it's filtered, you run this on the old stuff, and then we start developing on the new stuff on JUnit 5. Is that correct?
Yeah, absolutely. So you just use different annotations. I mean, in the best case scenario, it would be as easy as just running a find and replace and replacing these tens of thousands of tests from the old to the new annotations. But that's not how it's always going to work. So you can keep your old stuff around until you either gradually migrate it or you just keep it around and write your new stuff with the new model.
I know I'm kind of jumping a little bit ahead here, but let's say that's what I want to do. I'm a user. I want to start. I know I need to run these on JUnit 4. Is there a specific annotation I need to throw at the top of my test to do that, or how do I do that?
You mean to mark a test as having to be run with JUnit 4?
Yeah, the Vintage stuff, yeah.
Okay, no, the Vintage engine will do that on its own. It basically just looks at the annotation that a test is annotated with, and if it's located in the org.junit package, it knows, oh, that's an old test. Whereas if it's located in the Jupyter package, it knows, okay, I'm not touching that. You do that, Jupyter. I'm just dealing with my stuff that I know of.
Oh, that's awesome. So it's even less work that I have to do.
Right. It's just putting in the dependency. It's a runtime only dependency for the Vintage engine. And then if you drive your execution, it will just pick up what it knows how to handle.
Wow. It's amazing. So one quick thing, just to rewind for a second, you mentioned spec. For the folks that aren't familiar with spec, would you mind letting people know what spec is?
It's a test framework backed by JUnit 5 for I'm blanking on the name of the style of test that spec allows you to write. Oh yeah, okay. So basically, you write your tests in a different way, and they're kind of programmatically generated. So it allows you to write, for instance, for loops if you want to create multiple tests at once, and you have context. And it also facilitates. Does it facilitate BDD? I guess in a way, because you can logically group together your tests with a common setup, and then maybe you have a better approach at defining what spec is doing.
Yeah, it's just it's a testing framework built for Kotlin based upon a specification style testing. So if you're familiar with it, if people are familiar with it or want to learn about it, we're not going to dive into it today. I will provide a link in the show notes that you can check it out and kind of dive into it from there. But it's actually for Kotlin, so it might be something you're interested in. We'll put it in the show notes. Okay, so let's hop into some of the stuff here that you said inside of the Jupyter package, or the Jupyter, I guess the proper term is the Jupyter module, or whatever it would be, is where all of the kind of, as I was saying before, off the recording here, is kind of the meat and potatoes of where everything is at here. Now, what are some of these new features that are inside of JUnit 5 that I may be interested in initially as someone who's coming from JUnit 4?
One of the first things you probably notice going into JUnit 5 with the mindset of a JUnit 4 developer is the vastness of parameterized tests. I think that was the first feature that really wowed me. I knew how kind of painful it was to set up a parameterized test on JUnit 4, and the extensive capabilities that Jupyter gives us is mind-blowing, really. So that would be the first thing that would jump to my mind.
What is a parameterized test? There's probably folks that are like, I've never written one of those.
It's a test that is executed multiple times with different inputs. So as opposed to copying the same test method multiple times for each input, you just have one test method and you give it different inputs. For instance, if I wanted to check all the edge cases for a regular expression checker, we'd probably be here until the end of time if we want to write a validation engine for regex, but just bear with me. If we wanted to do that, and we would have, let's say, 20 different inputs that are or aren't valid, then we could just feed that into the test method as data, and that data would be a tuple of the actual input that we want, and then false or true based on whether or not we want this to be validated as true or false by the validation engine. And then we'd have a singular parameterized test, which would get these tuples as inputs, and then it would do just one set of logic, creating the validation engine, and then feeding in the input, and then checking if the result is false or true based on what the input gave us. So parameterized test allows us to minimize duplicated code. It makes it more powerful and concise to write, because there's different sources. It's called source in JUnit 5. There's different sources where these values can come from. So you can read them from the file on the file system. You can have a Java method return them to you as a list of arguments. You can write a CSV style comment block in the annotation. You can read it from JSON if you wanted to write an extension for it. So these parameterized tests have really been supercharged. It has been there before, but now it's insane.
Were you allowed to read from files and do all that other stuff in JUnit 4?
I guess if the question is, were you allowed? Yeah, probably. You could open a resource in your test method and then read in the CSV data line by line. It's just more convenient in JUnit 5 to just slap on the CSV file source annotation and just specify the resource name, and then have the already read in CSV file being passed to you line by line through a method parameter.
So it's just kind of much more user-friendly in JUnit 5.
Yeah.
So, and now if I want to start using, I know there's a bunch of features we'll talk about here. If I want to start using JUnit 5, and I know that JUnit is comprised of the platform, Jupyter, and Vintage, Do I need to pull each one of these into my project independently, or do I as soon as I use the JUnit 5, dependency, I just kind of get all of those?
I think recently there has been a artifact that kind of a bills of materials artifact that pulls in everything for you. And then everything would mean the Jupyter API and the Jupyter engine at runtime, because usually you don't need more than that unless you're a build tools guy. But usually it's in most cases it's going to be a two dependency integration. You integrate the Jupyter API interface. That's where all the annotations live, and that's going to be in the test implementation configuration in your Gradle file.
Okay,
and then the engine you would include as a test runtime only dependency. So you don't see it when you're writing your test. You don't care about how they're going to execute. But at runtime, it's there and it's going to be picked up by the platform. But you don't have to pull in the platform too. Gradle and IntelliJ, they provide that for you. They know that you're using the platform and they're going to drive execution through that.
So let's say I got those things pulled in. I'm ready to go. My dependencies are good to go. I want to write my first JUnit 5 test. What does that look like if I'm going to write a test? Can I just do what I've always done and create a file? Do I have to end it in the name test? Do I have to put an annotation on the class? Do I have to tell it is there a runner anymore? Or what does that look like? Let's just say we want to create a simple test that checks a value. Can you walk us through that?
Sure. So you create your test class first. No need to put a runner on it. Runners don't exist anymore, and the platform will know how to find your class if you annotate it correctly, but not on the class level. In your class, you put in the method, your test method. If you're writing it in Java, you don't need to make it public anymore. JUnit 4 test methods have to be public. For JUnit 5, it's enough for them to be package private. And then you slap the test annotation on it. If you're using JUnit 4 as well, you need to make sure that you're using the correct test annotation. The autocomplete in IntelliJ will help you. It's the one that has Jupyter in the package name. That's the one you want.
And that will run. That'll run it at JUnit 5 if I use the Jupyter one, right?
Exactly. That will run it with the Jupyter test engine. Then you put in the logic into your method, and then you hit the green run button. That's about it for a simple test.
So it's almost the exact same. I mean, it sounds like the annotation is the same. It's at test, right? It's not that hasn't changed at all. It's just a different import, right?
Yeah, it's just in a different package, so that it's picked up by a different test engine. That's pretty much all there is to it.
Now, what about the assertions? Have any of the assertions changed, or is there anything new that's been added?
There's a new assertions class that comes with the Jupyter API. And because we're in Java 8 land, most of the assertions make use of Lambda expressions, which were introduced in Java 8. And that makes it a bit more friendly to use. So instead of using, let's see, there's an overload of the assert methods of basically all of them. Assert equals, for instance, which you can at the end provide a lambda that generates the failure message. That's just a very just like it's not that big of a deal. But if your assertion message is kind of hard or like expensive to create, that might be good. A bigger seller would be an assertion method which is called Assert All, and it allows you to give it one or however many lambda functions, and then it will only pass the Assert All block if all of the lambdas themselves, if all of them pass. So you can kind of logically group together the assertions.
Oh, that's
and then
cool.
You have one block that will only pass if all of its children pass, pretty much. And it will also, I think, it will check all of the children, and then at the end it will say how many of those failed.
Okay, that's pretty cool. Then I mean, I like how they're using some of the new features in there. It kind of makes sense. Makes it a little bit easier to use, and I imagine this probably works pretty well with Kotlin as well.
It does. I think we have a couple of handy extension functions as well to make it even easier. So you don't have to. Most of these assertion interfaces are SAM interfaces, so single abstract method interfaces, and then the Kotlin extensions, they allow you to just pass a Kotlin lambda, so you don't have to instantiate the interface.
Oh,
it's just
nice.
that tiny bit more clean.
That's nice. That's cool. Excellent. Now, let's say I got a bunch of tests inside of my file, and let's say they're running on my continuous integration server, which we'll talk about in a minute. And for example, one of the things that one of my clients does is when we have a test that kind of becomes flaky for whatever reason, could be we've just set it up wrong, whatever reason, we'll end up disabling or ignoring the test, and then we'll kind of put a comment there and say, hey, this is we have a tech debt ticket to come back through and fix this test, and we put the ticket number there. Are some of those annotations still the same, like ignore, or how do I do that? Is it the same?
Well, the feature that itself is still there. It's just not called ignore anymore. The annotation you'd want to use is now called disabled, and it's the most bare bones implementation of conditional test execution that we have. There's a lot of different ways where you can or cannot execute tests in Jupyter. And disabled, you can just slap on a class or a method if you just don't want to deal with it. And it's very much better way to skip over tests rather than just commenting out the entire thing, because you do want the visibility. It does show up in the test report as a skipped test, and you do want to be reminded of the tech debt every time you make a build. So using an annotation like disabled is definitely the way to go there.
You mentioned something very interesting there, and that's conditional test execution. With ignore or disabled, that makes sense. But it sounds like there's some more to this. Can you expand on what JUnit 5 offers for some of this conditional test execution stuff?
Sure. It's basically the umbrella term for a whole set of annotations that allow you to, using external inputs, drive or skip tests. And there's quite a few of these annotations which usually come in pairs. There's an enabled and then a disabled pair. And you can look at different characteristics of the environment to make a decision about whether or not this test that is annotated should be executed or not. For instance, we can execute one set of tests only if you're running it on Windows. And then you can disable another set of tests if you're running on Mac, for instance. I guess for us Android folks, the OS level distinction is not as integral as if you were a desktop or like enterprise developer. But there's more. We can disable tests based on a value of an environment variable, and that really ties in with what Jupyter can provide to us for CI, for instance.
So what you're saying is that with the environment variable, like in continuous integration, I might set for a particular build, this build is going to set this environment variable, and then based upon that environment variable, I can then enable or disable a test?
Yeah, exactly. Or most environments like Travis or Circle, they usually advertise themselves as being CI through an environment variable that's also called CI. And then you can just annotate in your developer in your test code. You can just annotate the tests that are really slow, or just the ones that you don't want to always run until you push something to your repository. You can just annotate them and enable them if this environment variable is set to CI, and you don't get the penalty of having to run these small, slow tests all the time, but the logic is still verified if you push your code up into the cloud.
That's cool. So there's environment variables. You said there's OS ones. Is there any other conditional test ones?
Yeah, again, some of them are not really that necessary for us as Android developers, but you can enable a test if it's running on a particular Java version, for instance. So you can enable it if it's Java 9. You can disable it if it's Java 7. It also works with system properties. So similar to environment variables, if you pass a certain system property to your build system, for instance, or to the run configuration, if you're running from IntelliJ, you can skip or execute tests based on system properties as well.
Now, is there a way that I can write my own enabled or disabled if, like if there's some weird conditions that I want to meet in that regard?
Yes, behind the scenes, I think all of these are just a certain kind of extension that goes back into the extension model of JUnit 5. I'm blanking on the actual interface name that you have to implement, but I think it's something along the lines of conditional test execution, and then your custom annotation would be extended with that particular interface. And then it would get a shot. Jupyter would ask it, hey, I noticed you are on the test method. Can I run this test or no? And then your custom extension could say, oh, let me check. And then you do your custom logic and return true or false based on what you want Jupyter to do with the test.
Interesting. So then I could even write my own. I'm just kind of really pulling this out of thin air here, but maybe I have an app that's, it runs on, regular Android and perhaps also runs on Android Auto or whatever. That's, could be completely false here.
Mm-hmm.
But I could say, hey, I could write my own enabled or disabled kind of conditions saying, hey, if we happen to be running in a Android Auto environment, then go ahead and run this thing. Otherwise, don't run it.
Yeah, good idea. Or if you have specific device manufacturer specific quirks that you want to have tested because you know that only these kinds of phones behave this way, then yeah, exactly. So you'd have the Samsung condition disabled if Samsung, and then you just skip it if it's Samsung, because why would you bother testing it?
Exactly. Makes sense. That's cool then, because you can do, it seems like Jupyter is allowing you a lot of flexibility, as you said early on. It's like kind of has a lot of extension points into it. So let's continue on down here a little bit though. And I know that from what I had done a little bit of reading, is there some like BDD, behavior-driven development testing stuff supported in JUnit 5? Is that correct, or did I read that wrong?
You didn't read that wrong. It's not necessarily a BDD feature that comes with the framework itself, but it is greatly facilitated to write these kinds of tests with the stuff that they do give you. So there's an annotation that's called nested, and it allows for, in a nutshell, it connects the life cycle of an inner class to its parent. So that allows you to put a test class inside of another test class. And you know how there's these life cycle annotations, like run this method before each test and then after each test, and then there's another one at the start of the class and then at the end. Basically, if you annotate the inner class with nested, then you can be sure that every test in there in the inner class is going to be kind of connected to the parent's life cycle, and that allows you to put to really exercise these BDD style tests where the parent is the given portion of a test declaration, and then the inner class, that would be the when portion, and then the test methods themselves, that would be the then portion.
Oh, okay. So you have very BDD style for those that are familiar with that.
Yeah, exactly. It allows you to, in the parent, you just set up your common logic, your calculator object that every test is going to have. And each inner class could represent one of the operations that the calculator could do. And then in each inner class, there would be the tests that actually check something about the operation. And then you have these three phases. And it also makes for a really nice test report because they have a kind of hierarchical tree-like structure.
Interesting. Okay. Which I've seen. I mean, a lot of people have seen various different reports and probably conference talks on the similar type of output where everyone says, hey, you can give this report to your manager and they can read it like regular English and stuff like that. So we'll let people experiment with that. Now, I've kind of written down a few of the things I wanted to, I'm kind of confused about, and I was wondering if you could provide some clarity on. And one of them I saw in the JUnit 5 guide and so forth was something around argument conversion, or what is that?
That goes back to parameterized tests in a way. So I noticed, I said before that parameterized tests give the inputs to the test method. That's actually another difference to JUnit 4. Test methods can have parameters now. And in the case of a parameterized test, the source that you put on the test will just kind of extract the values and then give it to the method as parameters. So like for just like every other method ever, you just get the inputs as parameters on your method. Now the argument conversion comes into play if, let's say I have a parameterized test that is annotated with @CSV source. So that means in the test class, I put in the annotation a list of strings, and then each of the strings is represented of one invocation of the test method. And in that string, I put the input arguments. Let's say I want to have a name and the age of a person, for instance, and then I want to put that in under test. So each of the strings in the annotation is a comma-separated value, and then first it says, Alice, 24, and then the second element in that array in the annotation would be Bob, 48. So we would expect Jupyter to extract 2 test methods, like 2 invocations out of that, because I have 2 elements in the annotation.
Yeah.
And each of those has 2 inputs, the name and the age. Now, the argument conversion comes into play if when I write the method signature of my test method. So I can put the first parameter would be a string, would be string name. The second one, I can just say int age. The argument conversion basically means Jupyter can automatically make that stringified value of the annotation into the type that you need.
Oh, okay.
So you don't have to work with stringified values inside your method itself. And there's a whole bunch of different things built in. So it will convert locales, it will convert date times, it will convert currency, it will convert a lot of things for you. You can, of course, again, extend it if you like. And that's kind of another convenience feature for us.
That's kind of cool that it takes care of that for you, because I've dealt with other testing frameworks and other languages where I have all these inputs in a JSON file or something, and it just everything is interpreted as a string for whatever reason. And then I kind of have to kind of mangle the data to make it work. So that's kind of cool that they've thought of that from, right out of the box, which makes sense from what you said earlier on, is they wanted to make sure that they built this thing robustly and correctly the first time for JUnit 5.
Yeah, and also very versatile. So if you have your value objects, your database objects based on JSON, you can write an argument converter that just maps that to your actual class. So you get a person object in your method if you like. You just have to tell Jupyter how to convert from the JSON string to a person object. On the other hand, it can also infer that to an extent. That goes a bit in the magic territory, and the user guide will have more info on that. But you can really, really make use of this stuff.
That's really cool stuff. And one of the other things I also saw, there's a way to group tests with something known as containers. Is that something that I should be looking into? Is there only an advanced use of that, or what is that?
There'd be 2 answers. I think containers is also in the terminology of the user guide. It's their way of saying test class. So containers and then nested containers would be grouping into another container. To that, I would also reply, there's ways you can group together tests kind of from an ideological standpoint. You can tag different classes as being in a group. So you can mark all your classes that have to do with integration, for instance. You can tag those with integration. There's an annotation that's called tag, and you can give it a name. That's another feature that was there in JUnit 4. It used classes, though, instead of strings. Now it's just string identifiers. And the second one, though, in terms of grouping and like reusing test logic, that I really want to bring up because it's the second feature that blew my mind when I looked into Jupyter, test composition.
Okay.
So, you know how I said that, or like maybe I didn't, but I implied it, that JUnit Jupyter is built upon Java 8. So it requires Java 8.
Yeah.
And that means we can make use of the features that Java 8 gave us. And one of those is default methods for interfaces.
Okay.
Where you can have interfaces that have methods that actually do have some content, as opposed to before where that didn't work. Now, because that works, methods in interfaces can be test cases. So you can annotate the methods in the test interface, or like in that interface, you can mark that as test. Now, why would you want to do that? Let's say for each of your model classes for a database, for instance, you would probably have similar requirements for putting them under test. For instance, their creation or deletion logic, it's probably going to be a bit same. Now, before, we might have to make a base class, and then we have to extend from the base database test or something, and then we create our objects and do stuff like that. But like many other modern libraries, JUnit 5 favors composition over inheritance. So you can just put that common logic into an interface, kind of make that, you can name that model testable or something, I don't know. And then make that a generic interface, so it takes a type. And then each of your actual test classes for the person object, for instance, the person database tests, that would implement that interface
in the test class, right? The
exactly.
Test class,
yeah.
Okay.
It implements model testable of person, and then automatically you do get all the tests from that interface. So you can share the common setup logic that would be the same anyway without having to extend from a base class.
That totally makes sense because, like you said, especially in a database situation, I need to delete something is very common, and that's pretty easy. I'm going to take an ID usually, and I'm going to delete it in the database. That's usually going to be shared across various different types, and if I can, that allows me to just to save a lot of code, and then I can just slap that interface onto a number of tests, and I just get that test for free.
Exactly. You just have to write the interface in a way that's really can be shared and is generic enough to be shared by all the classes, but chances are that's pretty much the case if you're testing similar things like database models, which all kind of share similar responsibility.
Wow, okay. I can totally see why that's super useful. And especially if you're using something like generics, it allows you to really kind of make this a lot more, like you said, favor composition over inheritance. So you can really compose some stuff together. Now, one of the other things that really kind of piqued my interest when I saw the words inside of the JUnit 5 docs was the term parallel test execution. Now that sounds pretty fancy. Does that mean that I can speed my tests up by running them in parallel, or what does that mean?
It does mean you can speed your tests up by running them in parallel. That's exactly what it is. If your code base can handle it, you can improve your execution times by a great amount. So it can be enabled by Jupyter. And if it takes you 4 seconds to execute 4 tests that each take 1 second, then after it will just take 1 second because they all run at the same time. Now, there is a caveat. There are some requirements for your code. Parallel tests work best for code that can run in isolation. So there's no mutable state, right? These things are executed at the same time. If they execute and kind of access a shared resource at the same time, like input stuff into your mocked database at the same time, your test will probably become flaky because you cannot be certain that a certain test gets the inputs that it expects, which is an empty database, if another test has its hands at the same time on the same database.
Which makes sense. I think it's that even beckons back to the thought process of like, are you writing your tests correctly? They should kind of be hermetic in a sense where you can run them multiple times and doesn't do anything different. And you shouldn't really be, in my opinion, you shouldn't be sharing any state between tests. So I could see that how the mock database could kind of come into play, but I guess there's also ways around that too. So good point that you bring up there. That you need to make sure that you're not kind of messing with mutated state there.
Yeah, that's true. If all of your tests use a different database, they all have their own, then there's no problem. But if your code is architected in a way where you just mock out an interface for your database, but it's still going to be the same object in a way, even though you clear it at the end of each test, it's probably going to be mutated at the same time, and then you run into trouble. So unfortunately, it's not a drop-in feature that you just benefit from right away. But if you can, if your code allows for it, then it's a great thing to have.
Now, I've noticed when I was looking at the parallel execution stuff, there was something known as a resource lock that it'll execute your tests concurrently unless a resource lock is forcing execution on some particular thread. Do you have any information on that, or when or why I would want to use that?
Sure. It's a limitation of the parallelism and the concurrency that Jupyter can bring in a way that you can mark different tests where you know they are accessing the same thing at the same time. You can put a resource lock on them and give it, again, a string identifier. And you would maybe say, oh, these tests are both accessing the same database at the same time. So you would create a resource lock, and then you'd have the string value database in the name. Jupyter will know that these tests will interfere with each other if it did execute them concurrently. So whichever one it actually executes first, it will block the other one from starting until the first one is done. But that doesn't mean that it cannot run other things that have maybe other resource locks or that aren't locked at all. It will all execute them concurrently, of course. But for these two, it has now a special instruction to not do it at the same time, but one after the other.
Oh, okay. So then I can kind of still, if I run into that weird situation where like these 5 tests or whatever do kind of touch some file or whatever reason, then I can kind of group them together in that kind of resource lock, and then they'll just run sequentially one after the other or something like that. And then
exactly.
while the rest of the parallelization just kind of crunches away on everything else.
Exactly.
Cool. So now let's say I've got my JUnit test up and running, I've got some JUnit 4 stuff that's kind of running on the vintage stuff. It's using the old package. I've got my JUnit 5 stuff that's using the Jupyter package. Everything's running great locally. If I want to push this into my CI/CD server, continuous integration, continuous delivery, et cetera, that runs my tests, do I need to do anything different, or is it kind of just supported as long as I have my environment and my Gradle system set up correctly?
Yeah, if it's already there, then there's nothing you need to do. It's just another step in the build pipeline. The test task in Gradle will execute regardless. It doesn't care what kind of tests it runs. You don't need to set up your circle with anything. Now, the benefit comes if you do want to have the CI only tests in a way. As we talked about before, if you want to mark some tests to only execute on CI, that's where you put that in. But other than that, there's no setup logic for CI required at all.
I just thought of this. For when JUnit gets done processing, it usually has some type of JUnit report file. I believe it's an XML file, if I remember correctly. Did the format of that file change at all? Because I know there's some companies that kind of will pull that file down and kind of do their own analysis on it. Do you know if that's changed at all?
I think the original format was XML, and then there's also other tools that convert that into HTML and other formats. I don't know of any diffs between JUnit 4 and 5. I do know that there is still a test report, of course. It will report to you. It will report to you as XML. Maybe it's configurable to output different formats. I need to check that. And if I find anything, I'd put that in the show notes as a separate kind of section regarding test reports.
Perfect. Okay. Yeah. Cool. We can add that in there if necessary. Well, Marcel, this has been a ton of information about JUnit 5. It's super extensible. It seems like it's super powerful. The fact that I can kind of just take what I already have, add some new dependencies for JUnit 5, and everything else will just kind of continue working as it is while I can continue developing with the new stuff, is a humongous win and draw. And I think it's going to be a big draw for a lot of developers. I'd like to thank you for coming on the show. Are there any resources online that you would like to share, folks, to any links or anything like that where folks could learn more about JUnit 5?
So the user guide for JUnit 5 is one of the most extensive pieces of documentation I've ever seen. It might even be to the point of a bit too overwhelming in places. However, it's still the best resource. If you read that front to back, you're good to go. Now, I realize that's a bit heavy in a way. I do have a couple of talks over the years. There's a couple of talks that either I have given or other people have given on JUnit 5 itself. I'm linking 2 in the show notes. One is by my friend Danny Preußler. Mm-hmm. He gave a talk at DroidCon in NYC last year, 2018, about JUnit. It's called The Next Gen of Testing. That one is a good introduction to the features that we have outlined here as well. I'm also linking another talk by Mark Phillip, which is who's one of the folks on the JUnit team, and he gave a talk 2 years ago about the extension model. Now, the extension model is something that we haven't really discussed because it goes into much more technical details, but he outlines it really nicely in this 1-hour talk where he talks about what does it actually mean to put a conditional test execution annotation on your method and what's behind the scenes and how can we leverage that to our advantage.
Interesting. Cool. All right. Awesome. I'll make sure we get those into the show notes. And for folks that are also interested in learning more about JUnit 5, Marcel actually has a course on caster.io. It's JUnit 5 Fundamentals. You can go there and learn from top to bottom how to write a test, all the way through parallel test execution, resource locks. Everything we've talked about, I think, might be covered inside of that course. So again, we'll link that in the show notes if you're interested as well. And I'll also link in the spec framework testing, as well as the JUnit 5 user guide and the JUnit 5 Android plugin by Marcel. So Marcel, if folks want to get a hold of you, they want to ask you questions or anything like that, what's the best way for them to get a hold of you?
That'll be via Twitter. My handle is my full name, so @Marcel Schnelle. I'm going to make sure to put that in the show notes as well. Or just go to my website, which is a hub to all the things where you can find me, and that would be mann.de, and mouse is going to be the German spelling, so M-A-U-S, Mann oder Maus.de.
We'll add both of those to the show notes as well. Is there anything else you'd like to share with the listeners before we get going?
Do let me know if your instrumentation tests break on Android. Please don't share your frustration because it's Java 8 and it requires a very high API level to run on devices. Eventually, it will be more approachable for all devices. In the meantime, please let me know, let the JUnit 5 folks know what you want improved, what doesn't work, what you like as well, of course. And happy to hear from everybody.
Great. Well, thanks for listening, everybody. We'll catch you in the next show.
I want to thank Sentry for sponsoring today's show. Their tagline is, "Your code is broken, let's fix it together." They're a super cool crash reporting service that gives you all the helpful details that you need when detecting and fixing errors in your application. Don't wait for your users to report your errors and crashes. Use Sentry to catch them earlier. Check them out at sentry.io/for/Android. Once again, because Sentry is a common word, I want to make sure you get it right. Sentry.io. My thanks to Sentry for sponsoring today's show. That's it for the show, folks. Fragmented is hosted by Donn Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.